Hello everyone. Today we will look into simplifying radicals. The formal name for the square root symbol is called the radical. The expression square root of 9 reads as root 9, radical 9, or square root of 9. We have a few steps that we're going to go through. First, factor the radical into the product of perfect squares and other factors. Circle the factor that is a perfect square. Then evaluate the square root of each perfect square and write it outside. Rewrite as a product of a whole number and radical that cannot be simplified. Here's our first example. I have square root of 20. Square root of 20 can be written as 4 times 5. 4 is the biggest perfect square that can go into 20. Square root of 4 is 2 that can go outside, and 5 is not a perfect square, it will remain inside of the square root. Square root of 48 can be split into 4 times 12. However, since 12 can be split further into perfect squares, we can try to find the largest perfect square that can go into 48 at the first place. 48 can be split into 16 times 3, where we have a big number like 16 as the perfect square. We're going to take the square root of 16 and write it outside. Square root of 16 is 4, and square root of 3 is going to stay inside. Finally, I have 3 square root of 75. For that one, I'm going to use or split 75 into two parts, 25 and 3. I have 3 square root of 25 and 3. 25 can go outside as 5, and when it goes outside, it's going to multiply with the 3 that was outside, and the other 3 that's going to stay inside. My final answer is going to be 15 root 3. Here's your U-try. Please pause the video for a minute and solve. Here's the answer for our U-try. We split 28 into 4 and 7, and 4 can go outside as 2, which will multiply with 3 to create 6 root 7. Let's look at a couple more examples. My example this time involves multiplying two radicals. Here's how we multiply two radicals. We would multiply the inside of the radical with inside of radical and write the result inside. If I want to write a rule for it, I'll have a square root of x times b square root of y, which could be written as a times b, numbers multiply with numbers, they'll stay outside, and x times y, it will stay inside. I have square root of 3 times square root of 18. I can write this as square root of 54. Square root of 54 can be split later on into a 9 and 6, which we can simplify into 3 square root of 6. On the next example, I have 20 times 18. We can just go ahead and multiply 20 and 18. That will make 360. 360 can be split into 36 times 10. 36 is a perfect square, which will go outside as 6. Inside of the square root, we will have 10. Please pause the video and try the U-try too. On this example, we multiply the inside numbers and left them inside of the square root, and 2 that was outside remained outside. We got 162, which can be split into 2 and 81, and 81 is a perfect square that can go outside as 9. Then we have 18 square root of 2 as our final answer. Here's our next part. We are going to try to divide square root symbols, square root expressions. Whenever we are dividing square root expressions, we are going to first try to simplify them, and then we are going to rationalize the denominator when necessary. In order to simplify this square root 27, I'm going to split that into 9 times 3, and the denominator will split into as square root of 4 times 3. We can rewrite this problem as 3 square root of 3 over 2 square root of 3. Because the square root of 3 parts are matching, we can simplify them, and our final answer for this question is going to be 3 over 2. Next question is going to be slightly different. On the next question, we have 5 and 48. They are inside of the square root. So we can split the square root into two parts. Top is 5 and bottom is 48. I can try to simplify top and bottom separately. 5 doesn't simplify, but 48 was 16 times 3. It was in our earlier example as well. We can rewrite it as square root of 5 on the top over 4 root 3 on the bottom. Now we ended up with a square root on the denominator. When we end up with a square root on the denominator, we should rationalize our square root expression. Rationalizing requires us to multiply the denominator by its square root part. So I'm going to multiply the denominator with square root of 3 again. When I multiply denominator with square root of 3, I must multiply the numerator by square root of 3 as well. And I will continue my process with multiplying square roots. We have square root of 15 on the top divided by 4 square root of 9 on the bottom, which will turn into square root of 15 over 4 times 3, and we should write it as square root of 15 over 12. This would be our final answer. Please look at the U-try, simplify the square roots first, and then try to use the rationalizing step and simplify the answer as far as it goes. Please pause the video and try the U-try. Here is the solution for the U-try. We first split the numerator and denominator as much as they go, and then we simplify the square roots, and we have square root on the denominator, and we multiply the denominator by its square root part to rationalize it. It creates a whole number on the denominator eventually, and then we simplify our square roots and the fractions as much as it goes. Our final answer should be 4 square root of 3 over 5. That's pretty much it. Please make sure to bring any questions to the class.